There seems to be a lot of videos out there teaching you how to change to polar form if you're given a complex number. But I noticed that not many of them actually give you the formulas right away. So I'm making this video so you can just follow the formulas. Now the problem with this changing into polar form is that there's the preference of most engineers where they want the angle or the argument of a given complex number to be between negative 180 degrees to positive 180 degrees. And there's another convention that many mathematicians like, which is they want the angles to be between 0 to 360. So unfortunately, depending on the problem and how they ask you, you'll have to choose between these two different formulas. But they're not that different, so it shouldn't be a big problem, okay? All right, so how do you use this formula? Well, you probably already recognize the absolute value of the complex number, which is just square root of a squared plus b squared. And the other one, the challenging one, is this angle, where you have to do the tangent inverse, but then depending on which quadrant you're in, you have to modify your answer by this alpha. And to know what alpha should be, you have to memorize this picture right here. And that's actually everything. You just have to remember this picture. The reason we have the picture is because the tangent inverse gives you a number between negative 90 degrees to positive 90 degrees. And therefore, when it's on the right side, meaning when it's in the first quadrant or the fourth quadrant, first, second, third, and fourth. And when it's in the first or fourth quadrant, you don't do anything. But if it's in the second quadrant or third quadrant, you either have to add a pi or subtract a pi. This is assuming that you have radians. Of course, if you have degrees, then you should be adding 180 degrees here and then subtracting 180 degrees in the third quadrant. All right, so let me give you a demonstration of how to use this. So let's say you have z as negative 3 minus 4i. Or I think many engineers, they like j instead of I. So j is what most mathematicians call I. And let's say you want to change this into the polar form. First, calculate r, which is square root of negative 3 squared plus negative 4 squared. I see a common mistake being people including this j inside. Don't do that. It's just a number that you square. And therefore, this will be 9 plus 16, which is 25, which will be 5. Okay, now here comes the important part, the most confusing part, which is the angle theta. The angle theta should be computed as tangent inverse of, you have negative 4 as the b value and a as negative 3 as the a value, so you divide. But then you have to draw this on the complex plane and see what that means. The complex plane has the real parts and the imaginary parts here. The real part is negative 3, so here's negative 3. And the imaginary part is negative 4, so here's negative 4j. And then I should be using j. Yeah. Okay, and then this point right here is our given z, the complex number. And as you can see, this is in the quadrant 3. And according to this here, you have to subtract 180 degrees. Or pi, depending on what your calculator is set up to do and what the question is asking. Some problems might ask you to give the answer in radians, and sometimes they might ask you to give the answer in degrees, and you have to do it accordingly. All right, so let's do this. We're trying to find tangent inverse of 4 over 3. It's really negative 4 over negative 3, but that's what you have. And see, I have in degree mode, so it says it's 53 degrees. But because this is in the third quadrant, I better be subtracting 180. And that gives you 126.86. 126.86. So you have 126.86 with a minus sign. And therefore this, now in terms of the polar form, would be 5 angle negative 126.86 degrees. Now there's another polar form, see, this r angle theta is really just a shorthand for what mathematicians like to write it in the long form. It's this. So sometimes they might ask you to write the polar form in this shorthand way, or they might ask you to write it in this long form, which is 5 times cosine negative 126.86 degrees plus I times sine negative 126.86 degrees. So depending on the question, you should do this. And also, if the question was in terms of radian mode, I should do that also, just to do a demonstration. So I should change to radian mode, but this time I should be subtracting 2 times pi, right? 2 times 3.141592. There must be some pi somewhere, but I'm too lazy to look it up. So it must be this one. So that's negative 5.355. Negative 5.355. No, that's less than negative pi, so something's not right here. Oh, I subtracted 2 pi, sorry. I should have subtracted 1 pi. So let's do this again. Subtract 1 pi, and therefore it's negative 2.2143. 2.2, so negative 2.2143. So in terms of the radians, another answer would be this one, and this would be in radians. If you don't see a circle on the top, that means it's a radians, okay? So this is in radians. All right, let me briefly show you what happens if it's in the other one, okay? So we still want to do z equals to negative 3 minus 4j. But sometimes, let's say, the convention is they want the angles to be between 0 to 360. Now, from here to there, this is between 0 to 180 degrees. So in this new convention, there's not a problem. But in the old convention, these were treated as negative angles. So that's bad in this new convention. So if the question asks you to write it in polar form such that the angle is between 0 to 360 degrees, then instead of subtracting pi, you have to add pi, you have to add 2 pi, and of course, if it's in degree mode, you should be adding 180 degrees, 180 degrees, and this should be really 360 degrees. So whatever you do, you better have this memorized, and there are really 2 conventions. One convention is this one, 0 pi, negative pi, 0, and the other convention is 0 pi, pi, 2 pi. So you have to remember these 2 conventions and then remember these formulas, and that's it. You can always find the polar form of any complex number in any convention they use. All right, so let's quickly do this. So again, we already used the same r value. It would be 5. And then theta would be tangent inverse of negative 4 over negative 3. But this time in the third quadrant, you don't subtract 180, you add 180 degrees. So that's going to be, let's see, if you put in degree mode and change that into adding 180 degrees, then you get 233.13. So this would be 233.13 degrees. And just check that this is indeed between 180 degrees and 270 degrees, so that indeed you get an angle in the third quadrant, okay? So in that case, the answer would be 5 angle 233.13 degrees. And I'll skip the part where you do the radians. It should be straightforward now.